Good morning, guys. Today we're going to take a look at the next lesson on arrays of how to compare arrays. You don't compare arrays like you do regular primitive data types. And in the last lesson, it's going to be important what we remembered about copying arrays. We saw that you can't simply copy an array by using an assignment operator because remember objects have reference addresses. They're objects, they are not primitive data types. So if you simply use the equal sign, an assignment operator, to make two arrays equal, you're really not talking about the contents of the array. You're talking about their reference variables. So there are a couple more things we need to talk about because of that. But before we get into that, take a look at this program here. Pause the program and trace through the program. What do you think the program output would be? This is an important concept when working with arrays, and for those of you going on into the programming field and those of you going on into AP computer science next year, this is a very important concept that you're able to, one, trace code, and two, determine what's going on here. So pause the video for a minute or two, trace through the code, write down what you think is going to happen. So pause the video now, and when you're done, come back. Alrighty, welcome back. I'm not going to tell you what this code does. I would like for you to send me an email and tell me what you believe happens in this code. Alright, let's move on to the next slide here. Alright, comparing arrays. Now, just like when we said we determine if arrays are equal or copy arrays, we can't just set them equal to each other. We can't compare arrays simply by using the double equal sign, meaning is equal to. So the is equal to operator for arrays only determines if the addresses for the arrays are the same. It does not compare the contents of the array. So let's look at this piece of code right here so you can understand what I'm talking about. Here we have created two totally different arrays. One is called first array. Second one is called second array. They do both hold integers. And you can see that when we created these arrays, we did initiate them with the same values. Okay? Now in this next line, we say if the first array is equal to the second array. Now, while this is a good piece of code, a good statement, and a good if statement, what is really going on here is not what you think you might be doing here. When you use the is equal to operator, we usually use that on primitive data types to see if they are equal. But right now we are comparing arrays. Remember, arrays are objects, so they hold memory addresses. They don't actually hold the actual values that are stored in there. So first array is not going to be comparing its elements 5, 10, 15, 20, 25 to the second array, which also has 5, 10, 15, 20, 25. Instead, because they are different objects, they point to different memory addresses. They're actually comparing the memory addresses, and it is definitely going to return a false there. And we can plainly see that the two arrays are equal, but because of the way we have it written, it's going to return a false because the memory addresses will be different. So please, when you compare arrays and you want to see if they're equal, do not use the is equal to operator. It would be a mistake. So what this code segment would do here, it would go to the else statement and it would print the arrays are not the same. All right, so since the two arrays have different addresses, because they're different objects, it will return false. The correct way to compare arrays is like this. All right, so we'll use two different arrays, first array, second array. We will fill them with integers, just like you see here. Now, since we are actually looking at it, we can see that these two arrays are equal because they hold the same elements. But in order to compare them, we have to, first of all, create ourselves a Boolean variable, and we'll call this arrays equal, and call it anything you want. Now, we call this a flag variable. Whenever you're trying to determine if something's true or false, we simply start off by creating a Boolean variable and setting it equal to either true or false. And then we'll use that later on in our loops and stuff to change it if we need to. And we're going to be using a while loop. So remember, just outside the while loop, we have to create our index, which will control our loop, determine when it will end. And we first of all, if you're going to compare two arrays to see if they are equal, the very first thing you want to do is to determine if they're the same size, because there's no need to go through and compare all the individual elements of an array if they're not the same size, because if they're not the same size, they can't be equal. So the first thing you do, see if they're the same size. So here we're going to say if first array dot length. Remember, this is the length field, not a length method. We're not going to have parentheses afterwards because we're not comparing strings. So this is the length field. We just say dot length. If the first array dot length, so that means the length of the first array, is not equal to the second array dot length, if this returns a true, then the arrays equal, which is your Boolean expression, will be false. And down at the bottom, it would say that the arrays are not equal. But if this returns a false, meaning that the arrays are the same length, then this right here gets skipped and we move on down to the next line of code. Well, after we determine if the arrays are the same length, we move on into determining whether the individual elements are equal. So we say while arrays equal, okay, and we just determined that up top. We have our Boolean expression, arrays equal to true, or maybe it was changed here and it's equal to false. It's irrelevant. So while arrays equal, so if this is true or false, and I is less than first array dot length. Well, I is our index, so it's going to start off with 0. So and 0 is less than first array dot length, and we can see the first array dot length is equal to 5. So and 0 is less than 5. Well, this is going to be true for now. But remember, if we're using the AND operator, both conditions have to be true. So if this is false because this turned it false, this will kick out and jump down here anyways. So that means, that just goes to show that the while loop does not need to be inside the if statement. All right, well, if this is true, okay, because we set it to true up here and then this was false, so it didn't change it. So if this is true and this is true because 0 is less than 5, then we jump into the if statement to where it actually starts comparing individual elements. If first array sub I, that's the first element in first array, so that would be a 2, is not equal to the second array, the first element, which is also a 2. So if 2 is not equal to 2, which that would be false, it'll kick out and come down and start and increase the index and then run back through and make sure that this is equal again, or that this is true again. And it will continue back and forth until it finds one of these that is true, to where the first array element is not equal to the second array element, the same positions. Then it will make arrays equal to false, and then it will come down and increment again, and obviously this stays false at that point. Then we go to the display statements. If arrays equal is false, which if we found one that they were not equal, this would be true, so this will be false, it'll skip this one, and it'll come down here and print the arrays are not equal. But if as we compared each one of these, and it was true or false every time because they are equal, this Boolean expression arrays equal never would have been changed from true. It would have stayed true. And then when you come down here, if arrays equal or true is true, then it would print the arrays are equal. So I hope you followed that. We've done stuff like that with flag variables before. But the main thing you need to get from this example is when you compare arrays, you cannot use the is equal to operator to do it. You have to, first of all, check to make sure the arrays are the same length, because if they're not the same length, they can't be equal. And if they are the same length, then you need a while loop that will actually traverse through the arrays. And remember, traverse just means to move through. Traverse through the arrays and compare each individual element in the same position. And then as soon as it finds one that they're not equal, it will change your Boolean expression to false. All right, so make sure that you look at this piece of code. It's important, and you will be using it from time to time. All right, some other useful array operations are when you want to sum the array elements. Now, a couple of you tried to do that for me in the last programming challenge called rainfall. I didn't ask you to do that, but some of you went ahead and found the total rainfall for the year. And I said, that's fine, but I didn't ask you to do that. And you'd already figure out how to do that. I don't know if you figured out how to do it by looking in your notes or the textbook, or your good coding skills just made it seem very logical as to what you needed to do. You guys write some pretty good code, so I'm not surprised that you would have already been able to do this. I also asked you in the Rainfall Programming Challenge to find the average of array elements. The only comment I want to make on that is almost every one of you the first time through, when you found the average, you wanted to divide by a constant, a number, an integer that represented the length of the array. Now, since there were 12 months in a year, all of you wanted to divide by 12, which would have given you your average. There's no doubt about it. You would have gotten the right average. But remember, we write classes so that they can be used over and over and over again. So if you would ever want to use that class and you divided by 12 in that method, you would only be able to use that method on arrays that are of length 12. So you don't want to put a constant in there. You always want to use the length method. And you can see down here, whenever they actually find the average, average equals the total divided by scores.length. If this were the rainfall, you wouldn't want to say scores divided by 12 or total divided by 12, because that would limit the usefulness of that method in that class. So we always use the length field so that whatever the constructor builds, whenever the object is created, it will change accordingly based on that array that is built. All right. Now in your textbook, you can go in and look at a couple of programs. One is called salesdata.java and the other one is sales.java. Now, one of them is a class, the other one is a runner program. Just like I had you create in your last programming challenge called Rainfall, I had you create a Rainfall class that went in and built a constructor or built your array through the constructor. It found the average rainfall for the year and it found the highest amount and the lowest amount. And then I had you create a runner program that would send the values of the array either by prompting the user or you went ahead and just initialized your array whenever you created it. So you guys have already done this. This is just another example of how it's used in the real world. All right. As I said a moment ago, in the last program, I already had you guys find the highest value and the lowest value, and you guys did that very, very well. You guys had no problem with that because we had done it before and with other code, and you were able to see that arrays were no different in finding the highest and lowest values in a list of items. So you guys did very, very good with that one. So I'll leave that up to you to read through those notes, but you didn't have any problem with it, so I'm not going to beat a dead horse there. Now, let's talk about partially filled arrays. We had mentioned before when we first started about arrays that arrays have a limited usefulness, meaning that when you create an array, its size is fixed, meaning that after it is created, you can't lengthen the array and you can't shorten the array. So whatever size you pick whenever you create it, that's what it is and it cannot change. So if you're not sure about how large of an array to create whenever you're writing the code, you simply want to try to think about what's the largest value that it could be, and then you set it at that. Okay, because you don't have to completely fill an array when you use it, but if you run out of space, well then the array is no good, it cannot be changed, and a new array has to be created. So think about that whenever you're building your arrays. So here's an example right here to where they created an integer array called array, and they set its size declarator to 100. That means that it will hold 100 elements, but remember a subscript starts at 0, so its subscript values would be from 0 to 99. And here they're going to have some user enter in values. So if you're writing a program and the user gets to fill the array, you have to try to guess at how big this array should be based on what the user might want to use it for that situation. So this is why this person, whoever wrote this code here, created an array of size 100, not knowing how large the user would want this array to be. So You can see here in your print statement, it says enter a number or -1 to quit. So if the user is finished entering numbers, all they have to do is enter in a -1. The while loop will recognize that it's a -1 and kick out of asking the user for more numbers. However, if the user keeps entering in numbers, he can only enter in 99 numbers, because if he tries to enter in or 100 numbers, because the index is 0 to 99, if he tries to enter in more than what's there, we're going to get an error. So you might think, well, how do you get around this problem? Well, we stated that you make it large to begin with, or we have another method at the end of this chapter we're going to learn about, not a method, another class called an array list class that we will be talking about that does change size. So look through that. That's pretty simple. This is having the user enter and fill in the values of an array. But remember, arrays, when they're first created, have default values of 0, and they do not have to be completely filled. Just the elements that you don't fill, they remain zeros. Now we haven't talked about print writer, file writer, or anything since chapter 5, somewhere around in there, chapter 5, I believe, maybe 6. Early on in 6, we can save the contents of an array to a file, just like you wrote anything else to a file. So let's look at an example here. So we have ourselves an integer array called numbers, and we have the values 10, 20, 30, 40, and 50 in it. If we would like to save these values to a file, we simply do it just like we did it before. We call upon the printWriter class. We create ourselves a variable name. Here they call it output file. Equals new, because anytime that we're going to be creating a new object, we have to use the new keyword. So new printWriter, and then we're going to create a file called values.txt. So now that this file is open, what do you want to do with it? Well, we can see that we have a for loop here that will now print values to that file. So we start off at the beginning of the array at index 0, and we will continue writing to this file as long as the index is less than the numbers.length. Again, look right here. I chose not to use I is less than 5 because I don't want this to be limited. And what if I make a mistake counting the values in my array? So I don't want to make that mistake. So if I just use the array name.length, this takes care of how many are in there for me, and I don't have to worry about getting an index out of bounds error. And then we will increment one at a time through the array. And each one of these will be written into our output file one at a time using the print line method. So it'll start off by printing 20, then it'll print, or I'm sorry, 10, then print 20, 30, 40, 50, and then this will no longer be true, so it'll kick out of the loop and close the file. So just like text can be written to a file, we can write the contents of an array to a file. Now on the flip side, we can retrieve values from a file and put it into an array, just like you did with text. So we have ourselves an array that we created. We set it to size 5. And so we're going to pull out 5 values from a file. Here is our index because we're going to be using a while loop. So we always create our index just outside of the while loop. And to pull values or information from a file, we use the file class. So we call upon the file class. We create our file name. Remember, this is a programmer-defined file or variable name. You can call it whatever you want. Equals new file. And then you have to ask, what file are you going to be pulling from? So we tell it the file we want to go get the data from. And then we have scanner input file equals new scanner. We had to create ourselves a scanner object. And then we use a while loop to go and get that information. So while the input file has next, meaning while there are still values that are next, and I is less than numbers.length, we don't want to keep going and getting numbers out of a file that is greater than our array, or if there is nothing left in there. So we want these both to be true. If they are both true, then in numbers, starting at index I, which is 0, excuse me, we will write these values into that array. And after we go to the first element and we increment, and it'll go to the second element. We increment and it'll go to the third element, and so on until one or both of these conditions is no longer true. And then, don't forget, we always close our file. Alrighty, so that is it for this lesson. I'm not going to give you any exercises today. I would like you to at least watch this video once. Twice would be good. And tomorrow we're going to work just a couple of questions, writing a couple little pieces of code to exercise what we've learned here today. All right, have a good day.